Yeah, sure, you betcha. A is negative 4/3 and 1/2. B is negative 2 and 4/5. C is negative 1 and 5/2.
I think it's positive 1.
I'll check it in a sec. D is negative 1/2 and 9/2. E is negative 4 and negative 2/3, and F is negative 3/2 and 4/3. Now, Ayaka has suggested that she thinks this is positive 1. 1 squared is 1 times 2 is 2. 3 squared is 3. That would be 2 minus 3 minus 5 equals 0. 2 minus 3 is negative 5, or is negative 1. Negative 1 minus 5 is not 0. So it can't be 1. If it was negative 1, that would be negative 1 squared is positive 1 times 2 is 2. Minus 3 times negative 1 is minus negative 3, which is 2 plus 3, which is 5. 5 minus 5 is 0, so it is negative 1. Any questions? Going once? Going twice? Going thrice? You factor, you find the roots. If you know how to factor, you know how to do it. If you don't know how to factor, well, tough. Page 73. A. Negative 5 and 4. B. Negative 2 and negative 2/3. C. Negative 3/2. D. 25/2 and negative 2. E. Negative 9 and 4. And F. Negative 1/4 and 1 are my calculations. Is everybody happy with that? Does anybody need to see any of them?
F.
F? What? D and F. D and F. All right, let's have a look at them. D is right here. D is 2a minus 5, a plus 5 equals 21a. Yeah? All right. So the way I would do this is I would get it to where I am comfortable with it, which is 2a squared minus 25 equals 21a. 2a squared minus 50 equals 21a. 2a squared minus 21a minus 50 equals 0. Then I would factor it. Except that does not indeed factor. Does it? Let me check. 100. Negative 100. So 21. What would you do there? Because I haven't shown you the quadratic formula. Wait a minute. What did I do wrong? A squared minus 25, 2a squared. Negative 100. Factors of 100. 1 and 100, 2 and 50, 3 doesn't work. 4 and 25. Duh. A plus 4 over 2. A minus 25 over 2. A plus 2. And then you don't need to do anything there because it's minus 2 and 25/2. Okay? And Ayaka, you wanted F as in fudgical. 2x minus 1 equals x plus 1 over 2x. I would make that look like something I enjoy. 2x, cancel, x plus 1, 2x, 4x squared minus 2x, 4x squared minus 3x minus 1 equals 0. And then factor it. Negative 4, so it's, to add to 3, it's positive 1 minus 4. x plus 1 over 4, x minus 4 over 4. So it is negative 1/4, and that becomes negative 1, positive 1. Everybody cool? Yeah? Yeah. Now, how many people, now that you've looked at it, have no idea what to do with page 74? How many people are like, yikes? Okay, if I help you out a little bit, I'm going to let you try it a little more because I still need to pee. So I have two sides of a triangle that are perpendicular. That is this guy and this guy, yes? We all know what perpendicular means. And if we don't, what should we have done? Asked or looked it up. So this side is x plus 2. This side is 5x minus 3. The hypotenuse is 4x plus 1. I need to find x, yes? What do you know about the three sides of a right angle triangle? Think back to grade 7. Or if you're from another country, grade 2. A squared plus b squared equals c squared. These are the legs, that's the hypotenuse, right? So, x plus 2 squared plus 5x minus 3 squared has to equal 4x plus 1 squared. Now you should be able to do it, right? Expand it all, collect your like terms, factor it, tell me an answer. If you haven't done it, or if you got a check plus and you just had a bunch of work there without a right answer, because again, I'm here, I care about completion, now you should be able to do it. If you can't, talk to your neighbor while I pee. Okay, so in order to make your people's lives easier, I'm going to expand that in red, I'm going to expand that in blue, and I'm going to expand that in green. Now just collect your like terms. I'll collect this side first. Now I'll collect them all. Then I will factor. Then I will factor again. 30, it has to be negative 15 and negative 2. That simplifies to negative 3. So x has to be negative 3, right? Or, sorry, x has to be positive 3, or x has to be positive 2/5, yes? Right? Those are the only options, yeah? Even if you didn't factor it, you all should see how I got to here. Do you? Now you check. 3. What is 3 plus 2? Working with 3 in blue, that's 5. What is 5 times 3? 15. What's 15 minus 3? 12. What's 4 plus 3? Or 4 times 3? Plus 1? 13. Now let's check. What's 5 squared? 25. What's 12 squared? 144. What's 25 and 144? 169. What's 13 squared? 169. So is 3 work? Yes. if 3 works, I can check this one, or I can know that if 3 works, why would I even check that? Let's check. That would be 2/5 plus 2, right? Which would be 2 and 2/5, or 2.4, yes? That would be 2 minus 3, which would be what? -1. Is that possible? How do you have a distance that's negative? So it can't work. So it had to be 3. Everybody understand? Everyone understands how to find the answers to this equation. ax squared plus bx plus c equals 0. Right? If you're from another country, you're using the thing that I'm going to teach you in a couple of pages. If you're not from that other country, you solve this by factoring that. Everybody cool? Yeah? Going once, going twice, going thrice. And of course, once you factor, you all have to remember there's a couple of things that can mess you up. You can have numbers that don't work, right? Like 2/5. You got to check your work. Everybody good? Going once? Going twice? Going thrice? Sweet. Go to page 75. If I asked you to solve all of those by factorization, you would notice something very, very quickly. Let's just solve the first one. What should I do with that? X squared plus 10x plus 25. I need factors that do what? Multiply to what? 25 and add to what? 10. What are they? 5 and 5. So it's x plus 5, x plus 5, right? Look at 2. Do you see anything about 2 that is similar to 1? But what do you see that's similar? Why do you know that, Lucas? Why do you know that? What did you notice about x squared, 25, x, and 5? They're all perfect squares, aren't they? So what do you notice over here?
It's squared.
It's squared. So what is this automatically? X plus 3 and x plus 3. Or x plus 3 squared, yes? Great. So now it should take about 5 seconds to finish this. What's 3? X plus 7 squared. What's 4?
X plus 4.
Look closer. X minus 4 squared. What's 5? X minus 9 squared. What's 6? X minus 10 squared. Now, have you done the work or have you solved the problem? No, you have not solved the problem. When you solve a problem, you tell me what x equals. What does x equal in the first one? -5. What does x equal in the second one? -3. What does x equal in the third one? What does x equal in the fourth one? 4. What's x equal in the fifth one? 9. What's x equal in the sixth one? Does everybody understand? Is everybody good? So, if your equation looks like this, x squared plus or minus some coefficient with an x, possibly a y, plus or minus y squared, if these are perfect squares, right? Then you know this might work, yes? Now, what else did you notice? What did you notice about all the answers and the middle terms?
Divide by 2. Multiply by 2.
They're all multiplied by 2, yes? 5 was the answer, 10. 3 was the answer, 6. Everybody cool? All right. So, if you can get to this situation where b equals the square root of x, not x, sorry, where b equals 2 times the square roots of x and y, then you're in business, right? Everybody agree? Now, if it doesn't equal this, are you allowed to do stuff to make an equation look different? Here's what I mean by that. X over 3 plus 12 fifths equals 10. Could you do something to that equation to make it easier for you to work with? So you are allowed to perform stuff on an equation to make it look better, yes? As long as you do what? What is the one rule you have to remember? You got to do it to everything, right? Right? So what would you do to make this tidy? You'd do some algebra. You don't like that 3? You'd multiply everything by what? 3. You don't like that 5? You multiply everything by what? 5. You could get rid of both of them by multiplying everything by what? 15. Is everybody cool? That's like grade 8 algebra, right? Okay. So you all know you can do algebra to change the look of something to make it easier. So if this doesn't equal a perfect square, then we can manipulate to get a perfect square. Is everybody cool? Everybody good? Okay, so I'm going to write out the steps to do this. Okay, step 1. The first thing you always need to do is factor. If you can, right? Everybody cool? Okay, so 2. And I'm just going to write this out with letters. I know it makes no sense until you see it with numbers. Okay? X plus y squared equals z. And I'm just going to write it out, and you're going to see what I mean in a second. Okay? What would you do to solve this now? What would get rid of that squared? Divide. If I square root x plus y squared, then what do I have to do to the other side? Square root it, right? Everybody cool? Now, what does that give me on this side? X plus y has to equal the square root of z. Now, how many square roots does z have? How many square roots? Remember, in last unit, we were only looking for one root, the principal square root. But in reality, how many square roots does every number have? 2. What are they? The positive and the negative one, right? Everyone agree? So this is positive or negative, whatever the root of z is. Yeah? And then the last thing you do is you solve for x. Those are all the steps. And I know they don't make any sense until you see it with a number, right? The blank space over here is to explain a few things, all right? 1, z. this thing. You have to remember there's two roots. That's very important because when you square root something, you've got it there, yeah? Okay, so let's actually do one of these. Oh, by the way, whenever you see this instruction without using the GDC, that's a graphing calculator. Eventually, we will start working with graphing calculators, but not very often. Okay? So let's look at this. This, x squared plus 14x plus 49 equals 5. Look at it. Is that a perfect square right now?
Yeah.
Is it?
Yes.
This side is.
Yeah. But not the other side.
But am I able to solve with this just this side? No. I got to deal with that 5. So wouldn't that 5 have to come over here? Does everyone agree? Okay. So that's trouble, yeah? So let's look at our steps. What's the first thing I would do? First thing I would do is say factor. Oh, crap. I have to take this. This is my kid. Excuse me. Sorry, ladies and gentlemen. All right, so where was I? What were we talking about? Oh, right, okay. So, first thing is to factor that, right? So let's factor it. What is it?
X plus 7.
X plus 7 squared. Agreed? Okay. Now, that has to equal what? 5. Everybody cool? Okay. How will I get to x? Square root both sides. That's the next step. X plus 7. Right? Square root. So if I do something to the left, what do I do to the right?
Square it again.
Square it again, correct?
Yeah.
Well, square root, not square. Okay. So what now has to go here? Does 5 have a square root?
No.
So are we ever going to use the decimals? We stopped using the decimals, didn't we? So this is now plus or minus the square root of 5. Does everybody follow me so far? Everyone is good? Is x isolated yet?
No, not yet.
No, it is not isolated yet. So let's isolate it. Where does that 7 have to go? Other side and become what? Negative 7 plus or minus root 5. Now, can I go any further than that? No. X is isolated and we're done. Now, is this a real life number? Could I go to Home Depot and say I need negative 7 plus or minus the square root of 5 feet of lumber?
No.
No. But in math class, it's done. Because the root of 5 is irrational and doesn't end, right? Everybody cool? All right. Is this another easy one? Well, let's do that. Run through your steps on that side. And then see if you can figure it out. Step 1 was factor. Then solve for x. Go. It should take like a minute. Of course you can. Okay. What is this side? X minus 3 squared equals what? 6. Is x isolated yet?
No.
So let's start isolating. What do I got to do?
Square
Root. X minus 3 equals what? This is where you're going to make a mistake. Plus or minus the root of 6, yes?
Yes.
Then what?
And put 3.
Move the 3 over. So x equals 3 plus or minus root 6. Is everybody good?
Yes.
So, as long as we have perfect squares here, we can do this in our sleep, yes? So if I gave you, and you don't do this one, just look at it. If I gave you this, x squared plus 16x plus 64 equals 12. Could you do that?
Yes.
Yes or no?
Yes.
Right? Because this is a perfect square, yeah? Everyone agree? Okay. Look at this and tell me what's different.
It's not a square.
It's not a perfect square, is it? I don't have that third term trinomial, do I? So what I really have is this. X squared plus 10x. Then I'm going to leave a blank equals 6 because I'm missing my third term to make a perfect square. Right? That term's gone, isn't it? Yeah? Now, look closely. This was a perfect square, right? What is the relation between 14 and 49 and squares and stuff that will help us?
7.
Right, the square root of 49 is 7, and it's doubled, isn't it? What about this one? Square root of 6, 9. Square root of 9 is,
3.
and it's, how do I get the 9 to the 3 to the 6?
2.
I double it, right? Okay, so you can all see that if I have a square and I find the square root and I double it, I get this, right? So what if I need to work the other way? What do I do to the 14 to get to the 49?
Double it.
No. Going this way, 49 to 7, 49 to 14, I square rooted and I doubled. Now I need to go the other way. You guys all know how to do algebra. Reverse directions. Damaris. Divide by 2 and square it. Everybody cool? So, you have figured that out all on your own without me telling you, yes? It just makes sense. So what we get to do, completing the square, means we manipulate until we've got a perfect square. Everybody understand? So, step 1, as Damaris said, you all see the pattern. I square root and I double, right? Square root of 49, 14. Square root of 9, 6, right? We can see it. But in this case, we don't have that yet, so we reverse it. So step 1 is we divide the linear term. Now, I've written the word linear in capitals, and I'm going to highlight it blue. Linear because it doesn't have an exponent. It's this term. Okay? We half the linear term. That's step 1. So in this case, and I'll do that in blue, we half the linear term. That is step 1. So the linear term is 10. We divide by 2, and what do we get? 5. Oh, I should have done that in blue because I'm doing the whole question in blue. 10 over 2 equals 5. So I'm part of the way there, aren't I? Now, what was the second step?
Double
not double, square it. Because when we were working the other way, it was square root and half. So now we're double, or square root and double. So now we're halving and squaring. So then we square the result. The result of step 1. So that is 5 squared equals 25. Is everybody cool to there? Yeah? Okay, now I have something I can put here, don't I? What can I put there? Plus 25. Now, knowing what you know about algebra, what did I just add to the left side of this equation? 25, because that wasn't there before, was it?
Yeah.
So what do I have to do to the other side?
Plus 25.
Add 25 to keep it even. Now, what do I have? I have x squared. Oh, sorry. Now I can do this in my head, can't I? I should have pushed this over this way more. Oh, I missed the M. I left him there. Poor M. All by himself. Have you guys seen that new commercial for IKEA where they find the lamp on the side of the road?
Oh, yeah.
Have you seen it?
Yeah.
It's pouring rain and there's an IKEA lamp on the side of the road. Because, you know, people are too lazy to throw out their garbage. They put it down on the side of the road and hope somebody else will come along and take it. Like, you guys have all seen couches on the side of the road in the pouring rain, right? Who's going to take that couch? Nobody. It's because people don't want to pay $5 to take it to the dump. Anyway, so they put the lamp out and it's pouring rain and some little girl comes along and picks up the lamp. And then she takes it home and then they're doing all this stuff with the lamp. They're like doing crafts and things together. And then so the lamp gets a second life. And then it's pouring rain and that guy with the Swedish accent, who you never actually see because he's on the radio, he's a scary looking dude. And in the pouring rain, many of you feel sorry for or feel happy for this lamp. That is not crazy. It is better to reuse. And he's right. Anyway, it's a funny ad. I don't remember why. Oh, because I left the M alone over here. I'm reusing the M. That's why I thought that. So now we can do this in our head, yes? What is it? How do I factor that side? It is what?
X plus 5 squared.
X plus 5 squared equals what?
31.
31. X plus 5 equals plus or minus root 31. X equals negative 5 plus or minus root 31. Is everybody cool? All right, now, down here, let's fill this in. When do we use completing the square? If we don't have a perfect square trinomial, we're going to do this. All right? So, step 1. We need to set up the trinomial. Okay? Set up a trinomial. And a trinomial looks like this. There's a quadratic term, which is what? How do you know it's quadratic? I'll remember a trinomial looks like this, ladies and gentlemen. How do you know what the quadratic term is? Well, I just told you what a linear term is. It's the 10x. So what's the quadratic term? Right. It's going to have an x squared. And then it's going to be plus or minus a linear term. Your linear term is what? Bx. And then it's plus or minus a constant. And the constant is what is missing. Everybody cool? So, first you set it up. Then you do b divided by 2, and then what? What did I do? Oh. Cost goes till 11, right?
No, for 54.
Really? Does seem early. Well, I guess you're off the hook. Although you should, no, you're not off the hook. Do B and C, try them. At least.